Hi, this is Dr. Pan recording from Tucson, Arizona. Today we have a question from one of our YouTube subscribers. Let's do a quick analysis and see how we go about solving this one. To send your own questions, please consider subscribe our channel. Alright, the analysis looks something like this. When you have x squared adding a y squared and the coefficient in front of x squared and y squared are not equal, that's a huge hint that you have a curve of ellipse. Second thing is that we need to get this standardized form into something more readable and easier to graph. We'll use completing square, for example, to get into this form. Now, before we can graph this, let's do a quick analysis on ellipse. Ellipse is elongated along directions, and the direction its elongation is dependent on which number is divided larger on the denominator. If x squared term is divided by a larger number, then it's elongated along x-axis, and if the y-axis elongation is the number divided on the denominator is larger. So given those two, and one more thing about the center shift, that takes the form x minus cx and y minus cy. That's really just from the distance formula. So let's complete square on this form we're given and convert it into the form that's much easier to graph and go from there. Alright, so here's the solution. It looks tedious, but it's actually pretty simple. We copied all the terms over here, separating x and y's. For x, completing square is relatively easy. All you have to do is grab the coefficients in front of x, divide it by 2, and square it. Since you added something on the left-hand side, I balanced it on adding it on the right-hand side as well. For the y term, it's a little bit more complicated. We need to pull the coefficients out first. Then inside, we have y squared minus 6y. That's 18 divided by 3. And I'm completing square using the same formula here. Grab whatever coefficients I have, divided by 2, and square it. Now, since this chunk, the chunk that's in the box is inside 3 times, when we put it onto the right-hand side, we need to do exactly the same to balance the equal sign. Having gotten this part figured out, the rest is pretty easy. The x plus 3 squared, the plus sign follows this plus sign here, and the minus sign here followed along the y, so we have 3 times this chunk inside is a perfect square, y minus 3 squared. Clean this up a little bit on this side, we have 38. Dividing by 38, normalizing, we are into this formula, or this normalized form, we can graph more easily. Let's see if we can do a quick review and pull up the graph from before. Alright, so here's the graph that in the review we said elongated x and y direction and how to go about figuring it out. 38, we're going to write into the square roots of 38 squared. That's going to get into this form. Since x term is larger than the y term we're dividing, we're going to have a ellipse that elongated along x-axis. The center, remember, reading is x minus x and y minus cy. So here is x minus 3. That's why the center is at minus 3. For this chunk, it's y minus cy. Cy is positive 3 here. And from the center, all you have to do to read the distance is the length that's under the x-axis. That's minus or square roots of 38. Remember, this is a square term. And 3, that doesn't change. The y coordinate does not change. Similar for the other one that's on the other side. Let's go over here. So next slides, let's take a look at computer-generated graph for this particular problem. Alright, so here is the computer-generated graph. Here's the center at minus 3 and positive 3, elongated along x-axis. And to find the vertex over here, you need to go march minus square roots of 38 on one direction and positive 38 on the other direction. This turned out to be roughly minus 9.16. Well, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment, share, or like this video. Together we can make math easy again. Have a confident day.